We are starting now chapter 8. This is sequences and series. Okay, a little bit of thinking involved here. You guys are familiar with a lot of this stuff, I think. As we go through, just take notes along with me. And if you have questions, just unmute yourself and ask me and I'll stop. But guys, when we talk about a sequence, there's two kinds of sequences that we're going to talk about. There's infinite and there's finite. Okay, infinite, just like infinity, there's no ending. All right. There in an infinite sequence or series, there's no ending. It just goes on forever and ever and ever. Finite, there is an ending point. So we'll say has an ending. Okay. When I talk about terms, like the terms of the sequence, if I have 1, 2, 3, 4, one is term 1, 2 is term 2, this is term 3, this is term 4. You guys understand what I mean by that? If you are writing terms of a sequence, okay, you're going to have questions like this on your web assign. You'll have questions like this on a test or a quiz. It is very important that you guys show me work, because if you don't show me work, I promise you I will not give you credit. It's really important that you show work. So in this case, they're asking you to write the first 4 terms of each sequence. So all they're asking you to do is find the first term, the second term, the third term, and the fourth term. They mean plug in 1 for n, plug in 2 for n, plug in 3 for n, plug in 4. So in this case, you would say 3 times 1 minus 2. What's 3 times 1? 3 minus 2 is 1. So the first term of this sequence is 1. So if I want to find the second term, well then this is my term number. N is your term number, so I'd say 3 times 2 minus 2. So 3 times 2 is 6, minus 2 is 4. So the second term of the sequence is 4. If I want to find the third term, I plug in 3 for n. So 3 times 3 minus 2, 9 minus 2 is 7. And then the fourth term, I'd plug in 4. So I have 3 times 4 minus 2. 12 minus 2 is 10. So my sequence, my terms are 1, 4, 7, 10. And this could keep on going. They're going to understand that. Right? This is term 1. This is term 2. This is term 3. This is term 4. We good? Okay. That makes sense. So if I ask you to find the first 4 terms, this is what I need to see. On your web assign, when they ask you that, I don't want to just see 1, 4, 7, 10, because you tell me I did it in my calculator. Just write it out. It takes 2 seconds, but I want you to write it out. So in B, if I'm finding the first 4 terms, you're going to do the same thing again, guys. You're going to find a sub 1, the first term. You're going to find the second term. You're going to find the third term. And you're going to find the fourth term. So I have 3 plus negative 1 to the first power. Well, negative 1 to the first power is what? Negative 1. So 3 plus negative 1 would be 2. So if I find the second term, I have 3 plus negative 1 to the second power. Well, what's negative 1 to the second power? Positive 1. So 3 plus 1 is 4. Everybody with me? Okay, so then I have the third term. So I say 3 plus negative 1 to the third power. 3 to the third power is negative 1. So 3 plus negative 1 is 2. And then I have the fourth term. So I have 3 plus negative 1 to the fourth power. Negative 1 to the fourth power is 1. 3 plus 1 is 4. So in this sequence, it's 2, 4, 2, 4, and it just keeps going. This is term 1, term 2, term 3, term 4. Does that make sense? You guys with me? Okay, so that's when they give you a sequence and they say, hey, find the first 4 terms. Find the 7th term. Find the 20th term. If they said to you, what's the 15th term? Like if I took this, I think I have a note on this later, but a sub n equals 3n minus 2. I wrote it too. 3n minus 2. And they wanted you to find a sub 15. That means they want the 15th term. So you just take 15 and you plug it in for the n. So you would say 3 times 15 minus 2. 3 times 15 is 45, right? Minus 2. The 15th term of this sequence happens to be the number 43. Very, very, very simple. Questions? Unmute yourself if you have questions, guys. Okay. Let's go to the next one. Here, they didn't give us the formula or the sequence. They said, hey, find it. So this is why there's a couple different ways you can do this. This is how I tell everybody to do it. I'm going to write down my terms. My first term is 1. My second term is 3. My third term is 5. My next term is 7. Everybody understand what I did there? Just wrote down the numbers. Now, I'm going to say this is my first term, this is my second term, this is my third term, this is my fourth term. Okay, I always use this as kind of like an XY chart for writing sequences. And this will be very, very helpful when we do Wednesday's lesson, 8.2. We talk about arithmetic, whatever you want to say. Guys, I look at this as if it were an XY chart. Right? If we were going to find the slope of a line, you figure out how far or how much it goes up and down each time, adding and subtracting. If you're going to write the equation of a line, you need two things. You need to have the y-intercept and you need to have the slope. So what I do, if you have an arithmetic, and we'll talk more about this on Wednesday, but this is how I always set this up. I want to find the 0 term. This would be your y-intercept. And I'll explain this more on Wednesday, I promise. But your y-intercept, if this were an XY chart. So if you find the slope here, how much did I go up from 1 to 3? I added 2, right? Then from 3 to 5, I did what? Added 2. From 5 to 7, I did what? Added 2. So this is an arithmetic sequence, arithmetic, because you're adding or subtracting the same number every time. If you were to graph this would make a straight line. So then I'm going to say, okay, well, what would my 0 term be? What would my y-intercept be? Instead of adding 2 to get to the next number, how would I figure out the one before it? You subtract 2. So what is 1 minus 2? Negative 1. All right, so these two pieces of information are extremely important in writing this sequence. If I was writing y equals mx plus b, right, where m is your slope, and this would be my y-intercept, correct? So if I was going to write this sequence, the formula for it, what is your slope? What does it do every single time?
Add 2.
It goes up 2, so I would write, that's my slope, 2. And instead of an x, in our sequences, we use the letter n. And then what is our y-intercept? What's that 0 term? Negative 1. So there is your formula for this sequence of numbers. So you could check this. You could say, okay, well, if I plugged in 4 for n, what should I get out? If I plug in 4, what should I get out? 7. So plug it in here. What's 2 times 4? 8, and 8 minus 1 is 7. So that's right. Again, we're going to do this a bunch more. I promise. I promise, promise, promise. So now if I look at B, okay, I would do the same thing. I'm going to write out my terms. I have 2, 5, 10, 17. You guys with me? All right, let's figure this out. What is the pattern? How did I go from 2 to 5? What did I do? I went up 3, right? How did I get from 5 to 10?
5.
I added 5. How did I get from 10 to 17?
Up 7.
I went plus 7. Does this have a specific pattern? No. This does not have a specific pattern. It's just going up by an increment. So in this case, I wouldn't have you guys write a sequence in terms of this right now. Let me look. Hang on one second. Well, it does, because yes, it does have a sequence, and we'll talk more about this. I'm getting a little ahead of myself because we're going to differentiate between arithmetic and geometric. Arithmetic is when you add or subtract the same thing every time. Geometric is when you multiply the same thing every time. Do you see here, though, how we're not adding or subtracting the same number? Does that make sense? Okay, so if I look at this, because when you have a sequence, it has to do the same thing every time. So this one isn't arithmetic or geometric, but let's see if we can figure out what this sequence would be. This is the first term, this is the second term, this is the third term, this is the fourth term, right? Everybody agree? Yes? Okay, this is the term number, and this is the number itself. So think about this. Instead, what is happening the same time? The same thing every single time. We are adding, but we're adding a different number, so it's not an addition kind of thing. We're not multiplying by the same number every time. But let's think now in other ways. Let's think in terms of powers. If I think in terms of powers, what is 1 squared? 1? Yes? Then how would I get to 2? How would I go from 1 to 2?
You add 1.
Add 1. Okay, so let's think. What about 2? If I square 2, what's 2 squared? Plus 1 is 5. What's 3 squared? 9. Plus 1 is 10. What's 4 squared? 4 squared is?
16.
Plus 1 is? So what are we doing in this sequence?
So you square the sequence and then add 1.
You square the term number and then add 1 every time. So the way that you would write that is you would write n as our term number, so n squared plus 1. That's just getting you to think a little bit. I know some of you, Hannah, you're like, what? Huh? Don't freak out, I promise. They're just getting... I'm just getting you to think a little bit. That's it. Once we get past today, we're going to just do arithmetic and geometric, I promise. Just recognizing a pattern, because you guys saw that it was adding. It went by 3, then 5, by 7. But in order to write the rule, you have to write, it has to do the exact same thing every time. So in this case, it squared the term number, and then added 1. You could get it where it squares the term number and then add 5 or something like that. We're just thinking a little bit. All right, when I come down here for recursive, I think recursives are the funniest thing ever. It's just kind of silly, but in recursively means you're going to use the preceding term. Using preceding term or the term before. Using the preceding term to find the next one. We don't do a lot with recursive because it really and truly just doesn't make that much sense. So if they're telling you that the first term is 3, A1 is 3. All right, and we're going to try and find the next term in this sequence. They're always going to tell you, a recursive will always tell you what the first term is. They have to, because you have to use this in order to find the next term. So what this is saying is you're going to take this first term and you're going to plug it in right there. So to find the next term of the sequence, A2, I'm going to take 2. Instead of the A thing, I'm going to write times 3 plus 1. So 2 times 3 is 6 plus 1 is what? 7, right? So now I'm going to find the next term. Guys, with recursive, I told you have to use the term before it, correct? So now I'm going to say 2. Instead of 3, what was the term before it? 7. So I put the 7 there, plus 1. So I have 14 plus 1 is 15. Now to find the fourth term, I'm going to say 2, use the formula, but instead of 7, I'm going to use what? 15. And then I have plus 1 equals, so I have 30 plus 1 is 31. If I wanted to find the fifth term, I take my formula 2. Instead of 15, I'm plugging in this time what? 31 plus 1. You guys see what we're doing here?
Yeah.
This is 62 plus 1, 63. So your recursive series or sequence is 7, 15, 31, 63, and it keeps going. But recursive, you have to have the term before it to find the next term. So that's why it's kind of a silly concept. But all you do is just you're finding whatever term, you're taking the term before it and plugging it in. Taking the term before it, plugging it in. Taking the term before it, plugging it in to find the next one. Okay? We okay with that? Okay. Again, here, right? This is a recursive. They told me what the first and the 0 term are. We're not going to do a lot of these. I'm not going to get you guys confused with it. I'm just going to show you this. But look, they want you to use the first term. The term before it, and then the term before that. You're just plugging in. I will put this on the notes. Don't worry much about it. You're not going to see anything like this. I'm just showing you a recursive formula. Okay, factorial. This is really, 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 really easy, and it's really, really, really simple. You guys have a button on your calculator called the Factorial button. I'll show you in a second. Once at the end of this, we'll pull it up so you guys can see it. So I think I can stop screen sharing. Well, I don't want to mess up. If you go on your calculators, a lot of you have, if you look, unmute yourselves for a second so you guys can talk for a second. But there is a PRB button. Anybody see the PRB button?
Wait, Miss Meadows, I have a question.
Yeah.
This is going to be on YouTube, right?
Yeah. I'm doing explain everything right now. That's what we're doing this from. But you guys have a PRB button. Does anybody find it on their calculator?
I have to go to my calculator.
Okay, well, if you don't have it right now, it's fine. We'll talk about it. But Factorial, guys, if you see, this is called Factorial, the exclamation point. If you have like 4 with an exclamation point, that's just not really excited to yell 4. It's not like 4! All right, what 4 Factorial means, when you see that exclamation point, it means you take the number that's there, then you multiply it by everything behind it. Now, this can get tedious to write all this out, but I will show you on your calculator in a second. At the end of the video, I'll show you where it is on most of your calculators. What you need to remember, you need to write down, you need to always remember is right here. 0 factorial is always 1. Kind of like when you raise anything to the 0 power, it's 1. If you see a 0 with an exclamation point, that's 0 factorial, that means the answer is 1. Same thing with 1 factorial. Now, if you guys look here, when I talk about the values, 3 factorial is just 3 times 2 times 1. That's where we get 6 from. 4 factorial is 4 times 3 times 2 times 1. That's 24. 10 factorial. Look, it says right here, the value of n does not have to be very large before it becomes big. 10 factorial means you're multiplying 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now there is a button in your calculator that you can just hit 10 and then put the exclamation point and it'll do it for you. If you don't have your calculator, whatever, you can do this with a for function. You just have to write them all down. Everybody okay with that? Okay. So, if they ask you to find the first 5 terms of this sequence, again, you guys, you're going to have to do stuff like this in WebAssign. This is super easy. It's just calculator work, but I have to see what you're doing. So, if I want to find the first term, I have 2 to the first power over 1 factorial. Does everybody see that? What's 2 to the first power? 2 over 1. So my first term is 2. So if I'm going to find the second term, I have 2 to the second power over 2 factorial. Well, that means 2 squared is 4 over 2 times 1. 4 over 2 equals 2. You guys with me? Okay, so the third term, a sub 3, is 2 to the third power over 3 factorial, right? So 2 times 2 times 2 is 8, right? And then 3 factorial is 3 times 2 times 1. So it's 8 over 6, which is the same as 4 over 3. You guys with me? If I find the fourth term of this, I say 2 to the fourth power over 4 factorial. 2 to the fourth power is just 2 times 2 times 2 times 2. So it's 16 over 4 times 3 times 2 times 1. So it's 16 over 4 times 3 is 12 times 2 is 24. So then I can simplify this. 8 goes into both of those, right? Okay, so it's 2 over 3. If I find the fifth term, I use the formula 2 to the fifth power over 5 factorial. 2 to the fifth power is 32 over 5 factorial. That means 5 times 4 times 3 times 2 times 1. So 32 over, what's 5 times 4? 20. Times 3 is?
60.
Times 2 is?
120.
120. So this is over 120. And then I can simplify, yeah? Divide by 2. I get 16 over what? 60. Divide by 2 again. I get 8 over 30. Divide by 2 again. I get 4 over 15. Okay? This is not a terribly difficult concept, but you have to show me your work on WebAssign. I'm going to say this again. If all you do is just type in the numbers and write me a note that says, I did it in my calculator, you're not getting credit. Same thing on a test or a quiz. If we have a test or a quiz on this stuff, I need to see that you know what you're doing, so you have to write everything out. Make sense? Yeah, we're okay? All right. All right, let's do A here, and then we'll move on. I have 8 factorial over 2 factorial times 6 factorial. Common mistake, guys. 2 with an exclamation point times 6 with an exclamation point is not 12, like that. Those are 2 separate things, so keep them separate. Don't multiply them together. If I'm going to write all of this out so you guys see what I'm doing, I'm going to write this out on top. And I have 8 factorial. That means 8 times everything behind it. So times 7, times 6, times 5, times 4, times 3, times 2, times 1. And then on the bottom, I have 2 factorial, which is 2 times 1. And I also have 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Now, guys, when you have fractions, if you have something on bottom and top that is exactly the same, what can you do? What can we do if we have a number that's exactly the same on the top and the bottom? We can cancel them out. Do you guys see I have a 6 here on top and a 6 here on the bottom? Cancel it out. What else can I cancel? 5, 4, 3, 2, and 1. Right? Yes or no? Okay, so what am I left with on top? 8 times 7 is? 56.
56.
Okay, and 2 times 1 is? 2. And then what's 56 divided by 2? 28. Could you have multiplied the entire top? 8 times 7 times 6 times 5. Yes. And then multiply the entire bottom? Yes. And then simplify? Absolutely. But if you have something on the top and something on the bottom that is exactly the same, you could have stopped there. I could have also written this like this. 8 times 7 times 6 factorial over 2 times 6 factorial. How come I can stop right there at that factorial? What made me think, oh, I don't have to write the rest of those numbers out? Anybody?
Because you can already cancel out.
Yeah, you can already see that once I'm done with 6, then it's going to be 5, 4, 3, 2, 1. So you could have just gone like that. That would work out just fine. Okay? We all right? Factorials aren't hard. Okay. All right, now we get to this, and you guys are, oh my gosh. This is called summation notation. Some of you will learn about this soon when you go to college. That is the Greek letter sigma. Okay, this just means sum. Guys, what does the word sum mean?
Like
Addition. That's it. That's all you have to remember is sum means addition. So when I have this sort of notation, you guys are going to have problems like this, and you're going to be like, oh my gosh, how do I do this? Guys, this is easy. The number on the bottom is your starting number. That's the number that you're going to start plugging in. The number at the top is where you end or stop plugging in. Summation means to do what? Add them together. Upper limit means the top number. Lower limit means the bottom number. This is the starting point. This is the stopping point. And this is super duper easy, I promise. 2 minutes ago, you guys were doing like, I don't understand. Okay, look, here's my problem. Oh, I'm lagging. Here's my problem. Okay, they are telling me this is what they want me to use. This is the equation, or we'll say expression. They want me to start plugging in what number? 1. And they want me to stop when I plug in what number?
5.
And then what do I do to all the answers I get?
Multiply by.
Not multiply, no. This is summation. I'm going to add. So look, I'm going to plug in 1. And I get 3 times 1 is what? 3. Now I'm going to plug in 2. I'm going to plug in 1, 2, 3, 4, and 5. So when I say 3 times 2, I get 6. Then I'm going to plug in 3. 3 times 3 is 9. Then I'm going to plug in 4. 3 times 4 is. Then I'm going to plug in 5. And 3 times 5 is 15. Do you guys notice how I started plugging in 1? I stopped when I plug in 5. Everybody see that? Yes? Okay. And summation means what do we do to all these numbers? You add them. So, guys, what's 3 plus 6 plus 9 plus 12 plus 15? My answer is 45. Questions? Everybody okay? All right, look at the next one. Here's the expression they want me to use. And just what I'm doing, how I'm showing you this, guys, this is what I want to see on your web assign. But when I go through this, okay, what number do they want me to start with? What number should I start plugging in? Start with 3 and end with what? 6. So I'm going to plug in 3, 4, 5, and 6. Make sense? My calculator, my computer's lagging. Sorry. Okay, I'm going to go ahead and write, and then you guys will be able to see it. It's on the video. So 1 plus 3 squared equals. What is 3 squared? 3 squared is? 9. So 1 plus 9 is 10.
10.
All right. So now I'm going to plug in 4. So I have 1 plus, right? You guys with me? 1 plus 4 squared. So it's 1 plus how much? 16. So 16 plus 1 is 17. All right. Then I have 1 plus, I'm going to plug in 5. 5 squared. So I have 1 plus 25 gives me 26. Then I'm going to plug in 6 squared. So 1 plus 6 squared is 1 plus 36, which gives me 37. Very simple. Very, very, yeah. Yeah, it's just lagging a little bit. I'm sorry. It's on the YouTube video though. So guys, now look, this is just, guys, this is simple, simple, simple work. Very easy to make a mistake if you're not really paying attention to what you're doing. But now that we have those numbers, what is the summation? What do I do to those numbers? I add 10 plus 17 plus 26 plus 37. And I get what?
90.
90. So the summation of this is 90. That makes sense? Are we okay? All right, I'm going to stop.